Hi everyone, welcome to the Math 70 video lecture. This is section 5.1 and it is about finding greatest common factors. It takes a little bit of time to get to this idea though. So let's start with what are factors of numbers. A factor of a number, let's call this capital N. Factor of a number is a number that divides the number. Let me just give you an example. 2 is a factor of 6 because if you take 6 and you divide it by 2, you get a whole number as an answer. 7 is a factor of 35 because 35 divided by 7 gives you a whole number. 4 is a factor of negative 32 because negative 32 divided by 4, negative 8, gives you an integer. These are all factors. 5 is not a factor of 13 because 13 over 5 is 2.4, which is not an integer. That's what factors are. They're just numbers that divide bigger numbers. So how do you know if you have a common factor? Well, a common factor of 2 or more numbers, let's make that capital numbers, is a number that divides both or all of the capital numbers. So for example, 3 is a common factor of 12 and 15 because 12 is divided by 3 and 15 can be divided by 3. So it's a common factor. 7 is not a common factor of 2 and 24, of 14 and 24, because although 14 can be divided by 2, although 14 can be divided by 7 and equals 2, 24 divided by 7 is about 3.28 or so, which is not an integer. So 7 is not a common factor of 14 and 24. All right, we're making our way towards the greatest common factor because we know what factors are, and we know what common factors are. So the greatest common factor of 2 or more numbers capital numbers, is the largest number that divides both or all of the capital numbers. So for example, let's see, 6 is the greatest common factor of 12 and 30. Because 12 can be divided by 6, 30 can be divided by 6, and no larger numbers divide both 12 and 30. Three is a common factor of 12 and 30, but isn't the greatest common factor. Because 6 is larger, and 6 is also a common factor. So there are a number of ways to find the greatest common factor, but I like the way that involves primes, prime numbers, because it tends to be really flexible and always work, even if it takes a little bit longer. So finding the greatest common factor, GCF, using prime numbers. So let's define what a prime number is. A prime number is a whole number that can only be divided by 1 and itself. And we always, from our list of primes, we exclude the number 1, because that's just too simple. So numbers that can be divided by themselves, well, we have to exclude 1, that's in its own category. 2 can only be divided by itself in 1, and also 3. But 4, I can write as 2 times 2. So since I can divide it by something other than 4, it's not prime. 5 can only be divided by itself and 1. But 6, which can be written as 2 times 3, not prime. 7 can only be divided by itself. 8, I can write it as 2 times 4 or 2 times 2 times 2. And 9, I can write as 3 times 3. And 10, I can write as 2 times 5. So all of these numbers here on the right fail to be prime because they can be divided by numbers other than themselves. But 11 can only be divided by itself as 1. 12, that's easily to divide by 2 or by 3 or by 6 or by 4. But 13 can only be divided by itself. And so on and so forth. We add a couple more. Here are a couple more of the prime numbers. So all of these numbers here are prime numbers. Here's a nice fact. Any whole number is either prime, again, except 1, or can be written as a multiplication of prime numbers. So let's take a look at my list here. Every number in this list, excluding 1, is either prime or can be written as primes multiplied themselves. 2 times 2, those are both prime. 2 times 3, those are both prime. 2 times 5 are both prime. 2 times 2 times 3, all of the elements are prime numbers. So every number is either prime or can be written as the multiplication of prime numbers. For example, 24, well, that's 2 times 12. And 12 is 2 times 6, and 6 is 2 times 3, and these are all prime numbers. 2 is prime, and so is 3. 70, well, that's 2 times 35, and 35 is 5 times 7, which are all prime. This is called the prime factor decomposition. Decomposition means taking apart. And it seems abstract, but it's really useful when we need to factor things. For example, what numbers can divide 70? Well, 70 I can write as 2 times 5 times 7. Well, that means 2 can divide 70 because 2 is one of its prime factors. And 5 can divide 70 because 5 is one of its prime factors. 7 can divide 70, but so can 10, because 10 itself is made up of the same primes that are building blocks of 70. So all the factors of 70 are built from the primes that make 70 itself. And this fact right here allows us to find a greatest common factor very easily. Let's find the greatest common factor of 70 and 21. So step 1 is to find what are the primes in each. 70 we found was 2 times 5 times 7. And 21 is 3 times 7. 3 is a prime and 7 is a prime. And 7 is in both. That means 7 divides 70 and 27 divides 21. It's in both, so it is a common factor. There are no other shared primes. So 7 is the greatest common factor. Because 2, which is a factor of 70, is not a factor of 21, and neither is 5. And 3, which is a factor of 21, does not divide 70. So the largest number that divides both 70 and 21 is 7, and that means 7 is the greatest common factor. Let's look at another example, also involving 70. Let's find the greatest common factor of 70 and 24. And again, we start by writing 70 as its product. the multiplication of its primes. And let's do the same thing for 24. I did it earlier. It was 2 times 2 times 2 times 3. And in this case, there's a 2 in both. And even though it shows up more often in the 24, you have to pair it each time. The fact that there's only a single 2 in 70 means only one of the 2's in 24 counts. The 2 is the greatest common factor. Let's keep going. Let's do another one with 70. Let's find the GCF of 70 and 30. So we're going to start by writing both of our numbers with their prime factor decomposition. 30 is, well, 30 can be divided by 2, which is 15, and 15 can be divided by 3 and by 5. So now I have 2's in both and 10's, or sorry, and 5's in both. So 2 is a common factor. 5 is a common factor. But if both 2 and 5 are common factors, then 2 times 5 is a common factor. Because I have a 2 times 5 in the 70 and I have a 2 times 5 in the 30. So 10 is actually the greatest common factor because it's the largest of the factors of both numbers. So to find the greatest common factor, if you have more than one prime in your list that has a partner, you have to multiply all those primes together. Let's do one more example. Let's do the greatest common factor of 48 and 100 and no, not 100, 120. Okay. This can be a lot of work because you have to break each number down into its primes. And the easiest way to do it is to just start peeling off numbers one at a time. Well, I know 48 can be divided by 2. And 24 I can divide by 2 again. Notice how I keep track of my factors each time I'm splitting them off. So 48, if I wrote it as a product of its primes, would be 2 times 2 times 2 times 2 times 3. And then I'll do 120 over here. That's 2 times 60, which is 2 times 2 times 30, which is 2 times 2 times 2 times 15, which is 2 times 2 times 2 times 3 times 5. Okay. So now I have my prime factorization or my prime factor decomposition. And I just stack one above the other. And I look for shared primes. There is a shared prime. The 2 shows up as a partner 3 different times. And then I also have a 3 that shows up as a partner. So my greatest common factor is the 2 times the 2 times the 2 times the 3, which is 24. All right. Let's look at greatest common factors when we have variables also. And that's what most of this section is. Everything I've talked about so far is mostly getting us ready to look more closely at this section. Let's look at the greatest common factor of 10x cubed and 15x squared. We're going to use the exact same method here. We're going to write 10x cubed as a product of its primes. Well, 10x cubed is 2 times 5 times x times x times x. I don't know what the number x is, but I can list it 3 times as a multiple. And 15x squared is 3 times 5 times x times x. And now I'm just going to circle numbers that appear in the top and the bottom. 5 has a partner, so does the first x and the second x. And that's it. The 2 doesn't have a partner, the 3 doesn't have the partner, and my last x doesn't. So that means that 5 times x, or 5x squared, is the greatest common factor. Do one more example. Let's look at 24x to the 5th y cubed. And how about 30x squared y? So the first thing I'm going to do is I'm going to write the prime factorizations, treating my letters as primes. 24x to the 5th y cubed was 2 times 2 times 2 times 3. And then 5 x's. I usually get lazy and I don't write the multiplication. And then 3 y's. And 30x squared y is 2 times 3 times 5 with 2 x's and 1 y. And now I look for shared factors. There's a 2 that has a partner and a 3 that has a partner. X and X has a partner and Y has a partner, and that's it. Nothing else that isn't already circled appears in both expressions. So my greatest common factor is 2 times 3 times x times y, or 6x squared y. All right, with this understanding, now we can start factoring out a greatest common factor. From an expression. So let's look at, instead of just listing two terms, 10x cubed and 15x squared, let's build an expression. Like, let's do 12y to the 4th plus 30y. And we're going to write this with the GCF factored out. And we approach this by looking at each term separately and finding the GCF. So we're going to find the GCF of 12y to the 4th and 30y. So I write those as their prime factorizations. 12 is 2 times 2 times 3, and then I have 4 y's. And 30y is 2 times 3 times 5, and I have a single y. And now I pair. I have a 2 here. I have a 3 there. And I've got one of my y's. So 2 times 3 times y, or 6y, is the GCF. So far, the same as what we've been doing. But now we go an extra step. You also look for the leftovers. 12y to the 4 had a leftover of a 2 and 3 y's. So 2y cubed. And the 30y had a leftover of a 5. So step 1 is to find the greatest common factor. Step 2 is to look for the leftovers. And step 3 is to build the expression. You take your greatest common factor and you put it out in the front. then you open a parentheses and you add in your leftovers. GCF, leftover part 1, and leftover part 2. 6y times a quantity 2y cubed plus 5 is the expression with the greatest common factor factored out. And I can check that. If I build remember, I do remember now, I showed you all how to multiply polynomials. And this is a polynomial. 6y is a polynomial. And 2y cubed plus 5 is a polynomial. So let's do that. Let's build ourselves a polynomial multiplication where we have 2y cubed plus 5 on the top and 6y on the side. And we do our multiplications and we have 12y to the 4th plus 30y, which is exactly what we started with here. So factoring out the greatest common factor is basically the reverse of polynomial multiplication. Let me do another example. Let's rewrite, let's see, 56 x to the 7th minus 42 x cubed. 56x to the 7th minus 42x cubed with the GCF factored out. So the first thing to do is to write each term as its factorization. 56, now if you don't know how to do it, you might start by saying, okay, well, I do know that 56, because it's even, I can divide it by 2. And your calculator tells you 28. And 28 is also even, so I can split the 28 into 2 times 14. And 14 can split into 2 times 7. So 56 is 2 times 2 times 2 times 7. And then I also have my x to the 7th. So let me rewrite this whole thing. There's a good chance that pretty soon, as you're doing this, you're not going to want to take the time to write out all the x's. There is a pattern to factoring out the greatest common factor, but I like to write them all because that helps me see what's going on. And then the 42 x to the 3rd. Well, 42 is even. It's 2 times 21, and 21 is 3 times 7. So there we go. 2 times 3 times 7 times x times x times x. And now we match what we can. Let's see, these two matches and these 7s match. And then I'm going to get lazy. I'm just going to circle the 3 x's that match. Good enough for me. So my greatest common factor is 2 times 7 times x cubed, or 14x cubed. And my leftover part 1, 2 times 2 with 4 x's. 2 times 2 x to the 4th, or 4x to the 4th. And my leftover part 2 is just plain old 3. And so now I build 14x cubed times leftover part 1, 4x to the 4th. And I realized I made a mistake. I forgot about that minus. But the minus is very easily taken care of. You just put the minus in front of the term right there. And then your first, before you even put the 2, you just put a minus there. And it's not a leftover of 3, it's a leftover of minus 3. So my leftover, my second part is negative 3. And I can check again by using the rectangle method. I put the greatest common factor on the left, and I put the leftovers on the top. 4 times 14 is 56. X to the 4th times x cubed. Remember, we add the exponents. So it gets me 56x to the 7th. 3 times 14 is 42, and there's a minus, so it's a minus 42x cubed. And I get 56x to the 7th minus 42x cubed. So that's how you factor out the greatest common factor. You can do it if there are more than 2 terms. So let's do one more example, and then I'll wrap this video up. Here, let's factor out, so rewrite 36 x to the 7th y squared plus 24x squared y minus 40x to the 9th. By factoring out the GCF. So we're going to build our prime factorizations. 36x to the 7th y squared is 2 times 2 times 3 times 3. And you can work through that if you want to. And then 7 x's, 1, 2, 3, 4, 5, 6, 7, and 2 y's. 24x squared y is 2 times 2 times 2 times 3, and then 2 x's and a y. I'm just going to put the y's vertically. It's easier for me to see. And then again, since it's minus 40, let's put the minus 40 again. Minus 40x to the 9th. That's minus 2 times 2 times 2 times 5. And then 9x's, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we look for common factors. I've got a 2, and I've got another 2. But the 3, even though it shows up in my first 2 terms, it's not in the 40. So I can't pick the 3. I can't pick this other 2 because it doesn't show up in my 36, and I can't pick the 5. So I've taken all the numbers I can. And now looks like I have 2 x's that are shared. Ooh, and no y's that are shared across all of them. So my GCF is 2 times 2 times x, 4x squared. And my leftovers part 1 are 3 times 3, which is 9. 1, 2, 3, 4, 5. X to the 5th y squared. And then 2 times 3, which is 6 y. And then 2 times 5, which is 10. 1, 2, 3, x to the 7th. So these are the leftovers, which is not a bad thing. And so I will write it as my GCF, 4x squared. Oop, there's another leftover, the negative sign. I must be getting tired. I've missed that twice now. All right, the negative sign is super important. And if you're not tired and you're looking for it, that also comes along as part of the leftovers. And so I put my leftovers in, 9x to the 5th y squared plus 6y minus 10x to the 7th. And there I've written it factored out. All right, thanks for watching.